Hello everyone, let's start question 3. Question 3 says, state the transformations that are applied to each parent function, resulting in the given transformed function. Sketch the graphs of the parent function and the transformed function. That means for every part we have been given two functions. First is the parent function and second is the transformed function. Let's look at part A for now, which is my parent function is fx is equals to x square and my transformed function is y equals to f of x minus 3 plus 2. I am going to write the standard equation of transformation so that we can compare this equation with our standard equation. The standard transformed equation is y is equals to a f of b x minus h bracket close plus k. This is my standard equation of transformation. Let's compare the given equation with the standard equation of transformation. If we see we do not have any a here, that means there is no vertical stretch or compression happen to this parent function. However, if I compare inside the parenthesis, I do not have b. That means I also do not have any horizontal stretch or compression. Now moving forward, I do have a bracket with x minus something. That means if I compare x minus 3 with x minus h, the value of h is 3, which is a positive value. Since it is a positive value, I know that my graph has moved 3 units to the right. That means the transformed graph has moved 3 units to the right. This is the first transformation that has been applied to my transformed graph. If I continue comparing, I have plus 2 in place of plus k. That means I have k is equals to positive 2. K is positive, that means it has moved 2 units up. The graph has moved 2 units up. Now first of all, let me just try to graph the parent function. The parent function is x squared. X squared is a quadratic function. I know that the graph for the quadratic function is a parabola, and since I do not have any vertices for the parabola, the vertices for this given parabola is 0, 0. That means my parabola should look something like this. Perfect. Now, if I look at the transformation, the first transformation is 3 units to the right. That means if this parabola is at 0, 0, then 3 units to the right would be this is 1, this is 2, this is 3. That means the parabola starts from this point. Secondly, it has also moved 2 units up. That means if this is 0, 0, this is 1, this is 2. That means this point in here, 3 and 2. This is the vertex of my transformed parabola. That means my transformed parabola is going to look something like this. This is my transformed parabola. Perfect. So the graph with the dotted lines of white color is the original graph, the parent function, and the yellow one is their transformed graph. Now moving forward, if I look at part B, which is f of x is equals to 2 raised to the power x. 2 raised to the power any variable means this is an exponential function. And my transformed function is y f of x minus 1 plus 2. At this point, I expect you to start comparing this function with the standard equation of transformation on your own. That means the standard equation of transformation looks something like this: a f of b x minus h plus k. If I'll compare here, I know the two transformation that are being applied on this function are, first of all, I do not have any a, I do not have any b. That means I am again starting with x minus h. H is positive here because this bracket look exactly like this bracket and the value of h is 1. Also, the value of k is 2. That means even for part B, I have only two transformation, which is the transformed graph has moved 1 unit to the right and it has moved 2 units up, vertically up, horizontally to the right. Now let's move on to draw the sketch of the parent function and the transformed function. If I look at the parent function, this is 2 raised to the power x. That means this is a exponential function. This is an exponential function. If I put x is equals to 0, I am putting x is equals to 0 just to see where it is going to cut my y-axis. That means my y-intercept of the parent function, which is 2 raised to the power x. So y-intercept for this function is when x is 0. When x is 0, 2 raised to the power 0, anything raised to the power 0 is 1. That means my parent function is going to cut y-axis at 1. Another thing is, since this is an exponential function and I have only single variable x, this is going to look something like this. That means this is going to come from here. Yes, this is going to come from here, cut the y-axis at 1 and then move up as exponential moves in a asymptotic fashion, right? And then if I look at my transformed equation would be, it has moved 1 unit to the right. That means now every point that it has here, it has moved 1 point to the right. That means if this point is cutting this, if this graph is having this point as -3, now this point is going to be at -2. There is not going to be a lot of difference in the graph when I look at the whole graph, because this is starting from -infinity. So the transformed graph is also going to come from the -infinity. However, if I look at the second transformation, which is it has moved 2 units to the up, that means now in place of 1, it is going to cut my y-axis at 3. It is going to have y-intercept as at 3, 2 units up. That means my graph is going to look very much similar, but now it is going to, let me just draw it a little from below so that it has the same trend. So something like this. Very similar to the original graph. The y-intercept should be looking like this. So this is my transformed graph, the exponential graph for the transformed function, and the y dotted line is my. Now moving on to the C part, which is where my parent function is gx, is a trigonometric function which is sine of x, and my transformed function y is -2g 0.5x. Now see, if I am going to compare this function with the standard equation of transformation, all I can see is I have only two components here. First is -2. Now in place of f, I have g. So g is playing the role of f. That means -2 is representing what? It is a. So whenever a is negative, that represents reflection on x-axis. And here b, this is b. If anything that is being multiplied by x is b. If b is 0.5, that means 0.5 lies between 0 and 1. If 0.5 is lying between 0 and 1, that means if b is between 0 and 1, I have horizontal stretch. So 1 over b is actually 1 over 2. That means b is 2. So I have stretch of 2 units. Similarly, the reflection has occurred by a factor of 2. Now let me just try to draw the parent function and the transformed function both. The standard function, the standard graph of sine x starts from 0 because sine 0 is 0, and it forms the periodic wave. That means I'm only going to draw one wave in here, where it has 0 degrees at 0, and then it goes to 1 at 90 degrees, then it has 0 at 180 degrees, and then again 0 at 360 degrees, with -1 at 270 degrees. Similarly, I'm going to complete one wave on the negative x-axis, but I'm only completing one wave on this side as well. Now let's focus on drawing the transformed function. First is there is a horizontal stretch by 2 units. Horizontal compression by 2 units means now this up and down, 2 components of one wave has become one component. Another thing is, since there is a reflection on x-axis, what has happened is, starting from here at 0, 0, since the graph is going up, now the graph will start from here. But along with the reflection, since I have a stretch of 2 units, that means the 2 components of one wave has become one. That means it is going to, let me just draw a dotted line for the perfection first. It is going to look something like this. Now I am going to complete this wave on the negative x-axis as well. So it is going to look something like this, like a smooth wave. Yes, so this is how it is going to look like, where the reflection is represented by a reflection on the x-axis, and this stretch, the two components becoming one component, is given by b, because b has a stretch of 2 units. I hope all these three parts have made sense to you, and the methodology of solving them as well. So this d part, where I have the function g of x as square root x and transformed function y as negative 2g of 2x. This is very similar to the question C. The only difference is the graph of root x is going to look a little different from the graph of sine x. Maybe not little, a lot different from the graph of sine x. However, try to solve this question and let me know in the comment section, how did you find this question? Was this difficult? Was this easy? Or if you were not able to solve it, please let me know. I'll be more than happy to solve it for you. Moving on, this was third question in the Getting Started series for chapter 1. If there is any question you would want me to solve, kindly let me know. I'll be happy to solve that as well. Bye for now. See you in the question 4.